Jamb 2026 candidates, you all are welcome to today's lesson. And today's lesson, we are looking at efficiency of simple machine. All right, that's what Jamb suggested in their syllabus. I said we should look at that, ensure we are accustomed to that. Okay, so if you have anything you want to discuss with me, you need anything, you need lecture notes, you need the sharp plan for last minute preparation, just send me a message on WhatsApp. Okay, here is my WhatsApp number. Just add up and send me a message. All right, so let's look at what we have here. We have Jamb must repeat question 1. Read with me. A pulley system is used to lift a load. If the effort moves through 4 meters, while the load raises by 1 meter, calculate the velocity ratio, VR. All right. So, first of all, our normal style now, move right waiting they give us, okay? So that we don't forget what we define, all right? So, given, okay? So, they said, what did they say we should calculate? They said we should calculate velocity ratio, VR, all right? So, VR is equal to question mark, all right? So as easy as that, easy peasy. All right. Remember what I always say. I always say that anytime you finish reading any physics calculation question, the next thing you do is what? To look at the options. What are the options represented in? What units? But here, they don't even put units for the options. So manipulation no go work. We have to follow the rules. We have to use the formula to solve. All right. So let's look at what else we were given here. They said a pulley system is used to lift a load. If the effort moves, okay, see the effort here. Effort is 4 meters. Okay. So effort is equal to 4, okay, 4 meters. Let's put that. All right. So while the load rises by 1 meter, all right. So this one is the load. Load is equal to 1 meter. All right. The formula of velocity ratio is given by day down. All right. So if we substitute, we are going to bring effort here. Effort is 4 over 1 equal to what? 4. So our velocity ratio VR is equal to 4. So among the option, which is the correct option? Option D is the correct option. So we are done with velocity ratio. Let's look at the second question we have here. Okay. Jamb must repeat question 2. The question reads, a machine requires an effort of 50 Newton to lift a load of 200 Newton. Calculate the mechanical advantage. All right. So what do we do next? We look at the options. What units are they represented in? We don't know the units. No units. So what do we have to do? Let's write out what we were given. All right. So given what? What were we given? First of all, they said we should find the mechanical advantage, ME. ME, which is mechanical advantage, is equal to what? Question mark. That's what we are looking for. All right. So remember the formula for mechanical advantage. Mechanical advantage, ME, is equal to what? Load over effort. Okay, this is the formula for mechanical advantage. So let's write the other things they gave us, other parameters. They gave us what require an effort. This is the effort. Effort is equal to 50 Newton. Then the load is equal to what? Lift the load of 200 Newton. Load 200. And they said we should what? We should find the mechanical advantage. Okay. So what do we have to do? Do we have load here? Yes, we have load. Do we have effort here? Yes, we have effort. What do we have to do? We do what? We bring everything in. We substitute. MA is equal to load first 200 over what? 50. Therefore, our mechanical advantage is equal to 200 divided by 50, 4. Our answer is 4. All right. So, which of the options is correct? Which of the options is correct? Option B is correct, 4. All right. So, that's how to solve mechanical advantage and velocity ratio. But one thing, Jamb can give you something, okay? Maybe this formula that you can see here now, okay? This mechanical advantage formula, for example. Yeah? They can give you the mechanical advantage and ask you to find the load. What are you going to do in such situation? Does load have any formula? No. What we do is to make load the subject of the formula. Always remember subject of formula. So if they say find load now, you are going to make load the subject of the formula. Load is equal to what? You will now have this one, MA times effort. Okay? Or if they give you mechanical advantage, give you load, and they say you should find effort, you make effort the subject of the formula. Okay? When you make effort the subject of the formula, effort, okay, is equal to, you are now going to be left with load times what? Mechanical advantage. Okay, you are doing the same thing here. Okay, for this velocity ratio. Okay, they can give you distance moved by effort, and give you velocity ratio. They will not ask you what is the distance moved by the load. Just make distance moved by the load the subject of the formula. As easy as that. Very, very easy. Okay, don't fall for Jamb sheet tricks. All right. Now let's look at a question relating to the efficiency of a machine. Very, very common in Jamb UTME. Jamb must repeat question 3. The question reads: a machine has a mechanical advantage of 4 and a velocity ratio of 5. Calculate its efficiency. First of all, what are we going to do after reading calculation question? We look at the options. What are they represented in? Percentage. That's the one make if say our answer dey in percentage, okay, in percent. All right. So what do? We write what we were given. First of all, let's write what they told us to look for. Given, they gave us, what's the first thing? First of all, we are looking for efficiency. Efficiency, which is n, is equal to question mark. Okay. Then they gave us what? Mechanical advantage of 4. MA is equal to 4. Okay, they gave us velocity ratio of 5. Okay, VR is equal to 5. And they said we should find the efficiency. Okay, efficiency is equal to mechanical advantage over velocity ratio times what? 100%. Okay, so this is the formula for efficiency. So let's check if all we have here, whether we have it here. Do we have mechanical advantage here? Yes, we have. Do we have velocity ratio here? Yes, we have. So we can use it to what? To solve. All right. So what are we going to do? We substitute. Efficiency is equal to, what is mechanical advantage here? 4. What is velocity ratio here? Over 5. Okay. Times what? 100. Efficiency is equal to 4 times 100 is what? 400. Okay. 400 over 5. 400 divided by 5 will give us what? 80%. Do we have 80%? In the option? Yes, option B is correct, 80%. So the efficiency of this machine with a mechanical advantage of 4, velocity ratio of 5 is 80%. Always remember subject of formula. Always remember subject of formula. Always remember that. Always remember subject of formula. Always remember subject of formula. Jamb must repeat question 4. The Jamb must repeat question 4 we have here is, a machine is used to lift a load of 400 Newton with an effort of 100 Newton. If the effort moves through a distance of 5 meters, while the load rises by 1 meter, calculate the efficiency of the machine. Okay, this one is not straightforward like the former one. So let's do what? Let's calculate the efficiency. First of all, we look at the option. What are the options represented in what units? Now percentage you did. So let's write what we were given. We are going to write out what we were told to find, which is what? Efficiency. All right. Efficiency is equal to question mark. Okay, that's what we are looking for. Okay, so this is what we are finding, efficiency. Okay, so what did they give us? They gave us load. Load is equal to what? Look at it. Where is the load? Load of 400 Newton. Okay, 400 Newton. What did they give us again? They also gave us effort. Look at it, effort. Effort is equal to what? What else were we given? We were given distance moved by load. Okay, moves through a distance of 5 meters. All right, distance moved by load. We were given distance moved by load 5 meters. Okay, distance moved by load equal to 5 meters. Okay, were we given any other thing again? Yes, we were given distance moved by effort. Why? The load rises by 1 meter. Okay, the load rises by 1 meter. If the effort moves through a distance, now this one is the distance moved by effort. If the effort moves through a distance of 5 meters, okay, so this one is distance moved by effort, not load. Okay, distance moved by effort. Okay, then this one, distance moved by load, will now be 1. Okay, it's now equal to 1 meter. Okay, calculate the efficiency. Let's write out the formula of efficiency. Efficiency is equal to mechanical advantage over velocity ratio times 100%. This one is the formula of efficiency that we know. So what are we going to do? We are going to look at what we have here. Okay, do we have mechanical advantage here? No. Do we have velocity ratio here? No. So that shows that Jamb has concealed velocity ratio and mechanical advantage. They want us to look for it. So let's find mechanical advantage first, then we find velocity ratio second. Okay, so we can solve what we want to solve. All right, or let's find velocity ratio first. Okay, before we find mechanical advantage. Okay, let's find velocity ratio. VR is equal to what? What's the formula for velocity ratio? Distance moved by effort over distance what? Moved by load. Distance moved by load. Okay. All right. So if we do our VR, velocity ratio is equal to, we substitute. We have distance moved by effort here, and we have distance moved by load. Distance moved by effort is 5. Okay, meters. Okay, 5. Let me just put, or 5 meters. I don't already put that over 1 meter. Okay, 1 meter. Meter cancel meter. 5 divided by 1 will give us 5. So the velocity ratio VR is equal to 5. So VR, let's include it here. VR is equal to 5. We now have velocity ratio. So we are going to find what next? We are going to find mechanical advantage. We now have velocity ratio. Let's find mechanical advantage. MA, mechanical advantage, is equal to what? Load over effort. All right. So load over effort, that's the formula of mechanical advantage. So what are we going to do? We substitute. First of all, let's check if we have load and effort here. Do we have load? Yes. Do we have effort here? See the effort here. Effort is 100 Newton. Look at it with an effort of 100 Newton. So we have effort. This is the effort. It's with 100 Newton. So we have effort here. Okay. So load over effort. What's our load? 400. ME is equal to 400 over our effort, which is 100. Okay. When you solve this, divide 400 by 100, you are going to get ME. Okay, is equal to 4. Okay, so the mechanical advantage is 4. Okay, then MA is equal to 4. So since we now have MA and VR, we can now apply the formula of efficiency. Efficiency is equal to MA over VR times 100%. Then efficiency is equal to what? What's our MA? Mechanical advantage is 4 over velocity ratio is 5 times what? 100. And which is our efficiency is equal to what? This times 100. 4 times 100 is what? 400. 400 over 5. And which is our efficiency is equal to what? 400 divided by 5 will give us 80%. 80% is the answer. Is 80% among the option? Yes, option D is correct. See you in the next class.